Hello, and welcome to Lab 3, Part E, Bathymetric Measurements. Bathymetry. Bathymetry is the study of underwater depth of ocean floors and is the underwater equivalent to topography. Bathymetry is derived from the Greek terms bathic, meaning deep, and metry, meaning measure. In this lab section, you'll examine the bathymetric features along the North Atlantic coastline, the Northeast Pacific, and along Southern California. Passive margins. A passive margin is the transition between oceanic and continental lithosphere where there is no active plate boundary. The key characteristics of a passive margin include a broad continental shelf, then a steep continental slope, followed by a gentle continental rise, and finally a flat abyssal plain. A passive margin, visible along the eastern United States, all the way from the Gulf Coast to the North Atlantic, is visible. A bathymetric map of the coastline shows that key characteristics of a passive margin include, again, a broad continental shelf, then a steep continental slope, followed by a gentle continental rise, and finally a flat abyssal plain. But most importantly, notice that there is no active plate boundary along the eastern United States. The closest active plate boundary is the Mid-Atlantic Ridge. The North Atlantic continental margin is part of the North American plate, which is separated from the African and Eurasian plates by the Mid-Atlantic Ridge. Thus, because there is no active plate boundary along the eastern coast of the United States, the transition between oceanic and continental crust lithosphere is considered a passive margin. Active margins. An active margin is the transition between oceanic and continental lithosphere where there is an active plate boundary. The key characteristics of an active continental margin may be seen along the North Pacific coastline and include a narrow shelf and a trench. Additionally, there may be the presence of borderlands, as seen along Southern California. The Southern California borderlands are a series of islands and canyons that formed because of the bend in the San Andreas Fault. Movement along the bend causes compression. This squeezes the crust together, which forms wrinkles in the crust, creating the highs and lows of the borderlands. In both examples, active plate boundaries occur along the continental margin. Thus, the transitions between oceanic and continental crust are considered active margins. Active margin versus passive margin. When we compare the differences between the continental shelves on the western and eastern sides of the United States, we can see that the continental shelf on the western side is smaller and thinner, while the continental shelf on the eastern side is larger or broader. We can attribute the variance in size to tectonic activity. On the west coast, the margin is active. Thus, there's been less time for the continental shelf to develop. On the east coast, the margin is passive. Thus, there's been more time for the continental shelf to develop. Next, let's examine why or how continental crust lies beneath the ocean surface. There are two primary reasons. Isostatic equilibrium. Rigid lithospheric crust floats in a state of relative isostatic equilibrium. Thus, thinner crust floats lower, while thicker crust floats higher. Sea levels. As sea levels rise and fall, different portions of continental crust will be exposed or submerged. Now complete lab assignment Part E, bathymetric measurements. This concludes Lab 3. Please address your questions to your lab TA.